then let's start. Okay, so in 2023, the average internet user was studied, and basically we found out the average attention span is about 8 seconds. Now, some studies are more optimistic than that. Maybe it depends on the subject, on the person, but the key message is that we have a very short amount of time to impress our users. And first impressions are fundamental. Animations are one of the best tools we have to give a good first impression. As you can see, the problem is becoming worse over time because just a few years ago it was double. The attention span was double what it is now. So much that now a goldfish has a longer attention span than us. So welcome to this session. I am Raffaele Sorrentino, Android engineer at Qonto, which is a French B2B online financial institutions. And today's talk is about the importance of animations with the Jetpack Compose on Android. First of all, I want to make it clear, this session is not exclusively about UI. Animations can be used to have a nicer looking app, but it's not only for that. We can communicate with animations and use animations to talk with the user, to guide the user through the app. Look at this button, for example. It's not nice because there is no animation, and that's okay, but it's not only not nice, it's confusing. Because when you click on it and nothing happens, you would wonder, I would wonder as a user, did the click go through? Is the app frozen? Is it loading something? I don't know, because nothing is happening. On the other hand, while we had a simple ripple effect when the click is sent and a loading spinner, it's clear that everything is working as it should, and there are no issues. So we are effectively communicating with the user. And now it's easier than ever to use animations. You know, historically, animations have always been a pain point in Android development. This is because we were using XML files to render our user interface. They worked, but they were not designed for a complex structure. It's, you know, more or less the same thing that we face when doing web development. We have HTML files, but then we have to add JavaScript because HTML by itself is not enough. This is more or less the same thing. XML was not designed for complex animations. Now, instead, we have a more modern and robust framework, which is, of course, Jetpack Compose, and using animations is easier than ever because animations are built in the framework. So with this in mind, I hope you understand why animations are important and enjoy the presentation. First, we will look together at the major APIs that we can use to create animations with Jetpack Compose. Then we are going a little bit deeper and animate stateful composables. We will see how to transition from one screen to the other. And finally, we will have a look at animated vectors. The animations that you will see in this presentation have been used in a very basic example app, which is just tic-tac-toe. For the Italians in the room, it's tris, so very simple. When the app is open, there is a quick onboarding session where the app asks the user some questions like what's your name, how old are you, and so on. Then the user can play the actual game. We will not build the app from scratch, but we will just focus on the code used for animations. And then you can build the app yourself, or you can do something different, like 4 in a row, or whatever you prefer. Let's start from the most obvious animation, which is the appearance and disappearance of a symbol. We have the code to draw a symbol in the grid, but it doesn't show up in an animated way. It's not nice to look at. So to improve it, one thing we can do is to use the animated visibility function. Actually, let me turn my screen a little. Okay. We can use the animated visibility function. The way it works is we have a state which is content visible. This state is initialized to false, and it's used inside animated visibility. Then something happens in our logic. The state changes because the symbol should be rendered in the grid. And thanks to animated visibility, we have the symbol appear. The default animation used with animated visibility is a basic fade-in, fade-out. I'm using here a customized animation. We will look at the various options later. For now, the result is this, which is for sure much better than what we had before. Okay, now we have our symbols, but what about the grid? This is how the grid appears. Personally, I would not be very happy to play a game where the grid shows up like this. So let's try animating the grid appearance. First of all, there is no such a component in Compose as a grid. So in reality, what we are rendering here are 4 rectangles, 2 vertical rectangles and 2 horizontal rectangles. Rectangles can have a size, a width and a height, and what we try to do now is to animate the height and the width of those rectangles. We have our state again, is grid visible, it starts to false. Then once we turn this is grid visible to true, we use grid length, which is with the function animate dp as state. Now, what this function does, it's called an animation, but in reality what it does is transitioning from one value to the other over a certain amount of time. So we have the target value calculated as a function of the state. If the grid is visible, then the grid length is 350 dp, otherwise it's 0. So the rectangles are not visible. When the state changes, the target value changes, but the value contained inside this variable will not be 0 or 350, but it will start at 0, will end up at 350, and will have like all the possible values in between over 2 seconds. And we can use this grid length as just like the normal way we use any, in the normal way we add the width to any rectangle, which is just with the basic modifier dot width. And this is to animate the width. Of course, we are going to do the same thing for the height, except instead of using width, grid length, we use height, grid length. And this is the final result. So it's nicer. Actually, you see, for example, let's look at the 2 horizontal lines. These start from the left. This other one starts from the right. This is obtained not with an animation, but with an alignment, but it's the same thing for the animations. Now we have the transitioning from one content to the other. Let's see, for example, what happens when the game ends. Now we have our winning trees here, the 3 circles, and we have the code to detect there is a winner, but all in the matter of a single frame, the symbols and the grid disappear and the text appear. So we want to do something better. Something better can be done with the crossfade API. The crossfade API is something very similar to animated visibility, except with animated visibility, our state was a Boolean, is visible, true or false. In this case, we have something more complex, which is an integer. Actually, we only have 0 and 1, so it's basically the same thing, but it's just to say that you could have not 2, but 10 possible values, and it would work exactly in the same way. This is our state. The code in the game detects that there is a winner, and the state gets updated from 0 to 1. When this happens, there is an animation, thanks to crossfade, that transitions from the grid to the game over content. And this will be the result. Now, it's not the best of all possible animations, but at least it looks better than what we already had. Okay. Now, let's take a step back. I mentioned at the beginning of the presentation that there is, when the user opens the app, there is a set of questions, an onboarding, let's say. And this is what happens when user taps continue. The container, in the app, it's actually blue, like this background, but I put it in red so you can see better how the margin, the bounds of the container change. This is not nice. And to make it better, so yeah, something popped up on the Mac. To make it better, we can use animated content. Animated content is similar to crossfade. One could even say that crossfade is a particular case of animated content, and animated content is the most generic one. We are basically doing the same thing as before, except we don't have a completely different screen based on the state, that is question index, but we are building the content gradually. Like, we have a button. When the button is clicked, the question index is updated, and thanks to this, we show an additional question. It's very similar with what we had before. And again, about communicating with animation, animated content is a way we can use to tell the user the content is changing. We are changing the content with an animation, but you are looking at the same thing. We are not transitioning to a different screen or a completely different state, as in game in progress, game over. We are just updating what the user is already seeing. So it's another way we can leverage to communicate with the user. Now, when I introduced animated visibility, I mentioned there are several different transitions that we can use. The default one was fade in, fade out, and I was using a different one. Those are some examples of the different built-in animations. Fade in, fade out, this is the default one, or we can have the component shrinking and expanding, or sliding in, sliding out, horizontally or vertically. It's also possible to implement a completely customized transition, but this is not usually asked by designers. It's a very edge case, I would say. If your designer asks you to do that, they probably hate you. So find another designer. It's possible to customize these animations, as in making them slower. For example, this is the default one that takes 300 milliseconds, and this one takes a full second. So it's the same animation, just slower. It's also possible to combine multiple animations. This is fade in, fade out, expand in, shrink out, and those are the two combines. You can see while this gets smaller, it also becomes transparent. Okay, and that was it for the animation APIs. Now let's move to the stateful composables. So far, we saw how to animate an entire composable, the whole thing on the screen. But composables, especially in complex apps, can be even complex components. So maybe we don't want to animate the whole composable. We just want to animate a tiny bit of it. Usually, composables have a state. So let's see if we can animate a composable, a part of the composable based on its state. Can we do that? Yes. Otherwise, I will not be here talking about it, of course. To do that, we can use the animate as state API, and we already saw that when making the grid longer and smaller with the animate DP as a state. There are several different APIs, actually. That's not the only one. We can animate everything that came to your mind. This is the one we used earlier, but we also have animate integer, animate rectangle, color, floating digit number, anything you want. We can also animate a customized type. To do that, we use animate value as state. It works exactly in the same way, except we have to define a type converter, because we have to tell Compose how to transition from one value to the other of our own type, because it's our own. But once we've done that, it works exactly in the same way. Again, animate value as state, it's called an animation, but what it does is changing gradually from one value to the other. Let's see an example of using, we will use this one in the example, animate color as state. This is our grid, this is where we left the app. We have a winning trio, but it doesn't really stand out from the rest of the grid. Like, I point it with the laser, and that's okay, but otherwise you will not be able to easily see it. So what we try to do now is defining a state for each symbol, which is color. And we also define a logic to change our state. So what happens here is that we have our color, our state, and this is transparent. This is the background color we are going to use. At the beginning, it's transparent. Then once the code detects that this symbol is part of the winning symbols, the state changes to green. We wait half a second, it changes to red. We wait half a second, and it changes to green. The reason why I am I'm skipping through the colors is because I want to create a blinking effect. Like, it starts from transparent, then it goes to green, red, green, and it like blinks. Now you will see the result. So we have our state. The state always holds the correct value because of the logic in the previous slide. But the actual background color is defined as a function of the state thanks to animate color as state. So what happens is that when the state changes, the background color will gradually transition from the previous value to the new value over half a second. We have our background color, and this background color will be used just like any other background color. Okay? And this is the result. Okay, you see the blinking effect. What else? Yes, I prepared another example to show you how much Compose actually makes our life easier, because like, it's nice to look at these animations and see how the animations are implemented, but let's see at what are we missing from the old XML world. Let's say that I have a rectangle, which is this box, and a button. When the button is clicked, the state, which is color, just like what we had in the previous slide, the state changes to a new color, a random color. And this change happens, I mean, the state is updated immediately, but the actual color we use, color animated, moves to the new color over 4 seconds. So it's a very slow animation. What I will do in the next slide, or this one, is I'm clicking on the button before the current animation ends. You see? And it just works. I don't care about the animation life cycle. I don't have to stop the previous animation before starting a new one. I don't get conflicts. It just works. And it's really valuable when, as a developer, when you want to do something, you have to find the correct API, and then it just works without giving you a headache. What else? We can animate even multiple values at once. It's not really something you will find yourself doing very often, but with animate color as state, for example, you can animate a single value, which is the color. Otherwise, you can create this object, which is called transition, which is a function of the state. And when the transition is triggered, which happens when the state changes, it's always the same thing in the end. When the state changes, the transition is triggered. When the transition is triggered, these two values, height and border width, which are defined on the transition, will start moving from one value to the other at the same time. It's just a way you can use to coordinate multiple animations if you want them to happen at the same time. But again, it's not something you will use very, very often. Okay, now we will see how to navigate from the onboarding screen to the game grid. A full overview of how navigation works in Compose will be probably too long and also a bit out of the scope of this talk. So we will just focus on the code on the animations code. This is the code to implement the navigation without animations. So it's just the nav host without starting point, and two composables, two child of this nav host, questions and game. Now, I said this code doesn't have animations, and you don't see animations here, but in reality, animations are enabled by default in the nav host. So this code would have animations, and this will be what happens with the default animation. It's just fade in, fade out. So let's see not how we can add animations, but rather how we can customize them. To customize the animations, predictably, we just have to fill enter transition and exit transition in the nav host. What I'm doing here, I'm adding to the default fade in, fade out, I'm adding slide in horizontally, slide out horizontally, which is a kind of animation we see very often in commercial applications. And this is the result. Something we are very used to, I would say. We can have different animations, different transitions based on the composable. If instead of giving enter transition, exit transition to the nav host, we give it to the composable. In this case, each composable would have its own type of transition. It's also possible to fill enter transition and exit transition both on the composable and on the nav host. In this case, since the composable one is the most specific, it would win, and the one defined here for that screen will be ignored. Okay? Okay, we have the last topic for today, which is animated vectors. Most complex animations that you would see in the app use a library that is called Lottie. Lottie is a library created by Airbnb, used by available to Android, iOS, and other modern platforms. And it works in a way that is very convenient for designers. Designers can use Adobe After Effects or similar platform, but mostly this one, to create vectorial animations. Those animations can be exported as a JSON file. And if we import this JSON file in our app, we can render the animations natively on the various platforms where Lottie is available, so Android, iOS, and others. This is very convenient, especially for us developers, because it's very easy to use. We don't have to waste time implementing fancy animations idealized by designers. And also it provides a consistent implementation on all the platforms. Like, especially if we have an app that is available on web, on iOS, on Android, we get for free to have the exact same behavior of the animation on all the platforms. To use the library, we have to include the dependency in our module level build.gradle file using the compose version of the library. Then we add the JSON file in our resources folder. If you want to try it, you can find on Google many websites giving you free access to Lottie assets. This one was taken exactly from one of those websites because I don't know how to use After Effects, honestly. And yeah, look at this code. This is the code needed to render a Lottie animation, and it's exactly the same code you need to render an image. With the image, you create the pointer and point it to the correct resource, and here we have exactly the same thing. Now, what you see here is looping, because this one in the presentation itself is a GIF file, so it loops. But in reality, in the app, this would only be executed once. If you want a GIF effect, you need a state, which is animate Lottie composition as state. You specify iterate forever, and then you will get a GIF, basically, in the app. And usually it's much better to use a Lottie animation or anything other than a GIF because of compression issues. Like a GIF file, usually it's very, very big because it's a set of images, while with vectors we can get even a long animation for just a few kilobytes. That's it. Anyone has any question?